In fact, emission rate mode, my coworker has introduced the default inventory mode and custom activity mode on the left side of this chart. And on the other side, EMFAC can be also used to generate emission rates, and which is also called the PL mode, project level assessment mode. So what is a project level assessment? A project level assessment usually assesses emissions at a much smaller scale than a regional inventory. For instance, it could be a link of highway, a freeway intersection, or a parking lot. Project level assessments are required to meet conformity requirement or CEQA requirement. The chart here shows an example of a freeway link project. I believe this is a section of I-5 located in the Los Angeles County within the boundary of South Coast Air Basin. So when should we use the PL2? As Cassie introduced earlier, if all the modeling conditions are consistent with the default assumptions, users can use the web database to get emission rates directly. That will be discussed further by my coworker Han Liu right after my presentation. However, in a typical project analysis, users are often required to obtain emission rate under specific custom input condition, such as temperature, humidity, or speed. In this case, EMFAC PL will be the right tool for you to use. The significance of EMFAC PL is that it provides refined emission rates at user-specified temperature and speed, humidity and speed for any vehicle classes or group of classes. And it can also be produced by specific model year or fuel type. So next, I'm going to show how to use the PL mode to generate custom emission rates using 4 demo cases. The first demo scenario is a typical link project with truck and non-truck fleet mix, where we are interested mostly in the running emissions. The second demo case is an interregional bus terminal. The vehicles engaged in the interregional transportation are diesel motor coaches. And the main emission process that we are interested in is the idle emissions. The third case is also a bus terminal, but this time it's for urban bus. What makes it different from the second case is that, in fact, urban buses do not have a separate idle emission process. So this is a special case, and we will provide a special solution. The last case is a park and ride parking lot, where the major vehicles are commute vehicles, including light-duty auto, light-duty trucks, medium-duty trucks, and motorcycles. For such a parking lot project, typically we are interested in the start emissions and evaporative emissions, including hot soak, diurnal, and resting loss emissions. In reality, you might have to deal with more complicated cases. However, you can divide a complicated case into smaller cases like this by location or by vehicle classes or by process. Since all my demo cases are characterized by different process, and also, as my coworker mentioned earlier, in the emission rate, output from the PL mode are always specified by emission process. So to facilitate the following discussion, here in this slide, let's do a quick review of the emission process used by the EMFAC PL. As we will see later in the demonstration, the output emission rate are always specified by temperature, humidity, speed, or soak time. Depending on the process, emission rate may or may not vary by any of the 4 particular factors. For instance, the first 3 rows shows the running exhaust, while the exhaust emission. The first one is running exhaust. The running exhaust emission rate vary by temperature, humidity, and speed. However, the idle exhaust emission rate does not vary by any of the factors. Start exhaust emission rate vary by temperature and soak time. After that, we have six evaporative emission process, including hot soak, which is the emission from the vehicle within a short period after the engine has been turned off and the engine is still warm. And running loss is the evaporative emission from the car that's operating or running. Partial day resting loss evaporative is the evaporative emission from a car resting on parking lot less than 24 hours and while the temperature remains the same or declining. So multi-day is similar, but it's more than 1 day. Diurnal refers to the emission evaporative emission from a car sitting on the parking lot when the ambient temperature is increasing. So all 6 evaporative emission process emission rates vary by temperature. The last 2, brake wear and tire wear, are PM emissions. Emission rate does not vary by any of the 4 factors. With that in mind, let's take a look at our first case. The first case is for a project for lane expansion on existing arteria. We assume that this project is located in Sacramento. Analysis year is 2020. This area is in non-attainment of the annual PM 2.5, so the pollutant PM 2.5 will be the major pollutant that we are interested in. We assume the analysis will be performed for 4 periods of a day, which is consistent with the typical travel demand modeling. That is morning peak, midday, evening peak, and overnight. We also assume we know the VMT by truck and non-truck split. The average link speed for this simple example, we assume is 30 miles per hour for all periods of the day. Users also are expected to collect the meteorological data, including temperature and humidity, respectively, for the 4 periods. Okay, now let's go to the EMFAC model. The PL mode is triggered when you start a new project and click the emission rate. As you can see, the only run type option is project level assessment. Now click Start. For the first example, it's located in Sacramento. The sub-area and the county for Sacramento define the same boundary, so you can either select sub-area or county. Next. On the next tab is calendar year. Pick 2020. We assume this is an analysis for annual. In the next tab for vehicles, since we recommend that the user pick the vehicle classification based on the level of detail of their VMT data. In this case, the VMT is specified by truck and non-truck, so we pick that option and select both entries. And in this example, we assume we're not aware of the VMT split by model year, neither by fuel type, so we keep these 2 options as the default, which is aggregated. In the speed bin selection, pick the link speed 30 and go to the next tab. Here, meteorological data is the tab where you input your custom specified temperature and humidity. Now I'm typing 4 pairs of values. Each pair of value is a temperature and humidity for a specific time period. So for instance, now it's 75 temperature in Fahrenheit, and 38 stands for the 38% relative humidity. That's for the midday. Next is for the evening peak. Temperature 80, relative humidity 28%. Then the last one is for the overnight. Temperature 58, relative humidity 50%. With that done, you can use this button to validate that your input are in correct format. Click Next. By default, all the pollutants are selected. So if you have a specific pollutant in mind, you can just uncheck and select the particular pollutant. Alternatively, you can do the filtering on the final output. So the other options on this tab are whether you want to split output by sub-area and calendar year. Since we are only doing one sub-area and one calendar year, that doesn't matter. And also the output default directory. You can change any directory here. Now click Run, and the model will automatically remind you to save the run specification first. You can name it. So this is some pre-generated run specific. You can replace the existing one, or and click Run. Now while the model is executing, this particular example takes about 3 minutes to finish on this laptop. So I'll terminate this run, queue this run, and show you the result that was pre-generated directly. So this is the output for our first example. As you can see that here emission rates are produced by calendar year, season, sub-area, or which is always the smallest geographic level, and vehicle category that user selected at specific temperature, humidity. For this case, since we are interested in the running emissions on a freeway link, what should we do is to filter the result first by the process. So the process on a freeway link is running exhaust, running loss, PM brake wear, and PM tire wear. Okay. To get a better view, I'll just pick one pollutant, PM 2.5, and show the structure of the output. So here we have the emission rate by different process. For running exhaust, the emission is always specified by temperature and humidity. For brake wear, tire wear, the emission rates are not specified by temperature and humidity because the PM emission rate does not vary by these two factors. Now let me close this the output, and come to the second example. The second example is for a motor coach bus terminal. So motor coach is a category added in EMFAC 2011. It refers to the specific body type of buses that engage in interregional transportation and are regulated by the truck and bus route. Here, the main emission process we are interested in is idle emission. We assume in this example that the modeler has better knowledge of the fleet composition. So in this case, the fleet consists of model year 2000A and model year 2014 motor coaches only. Temperature and humidity are not a factor that influence the idle emission rate, as I will show you later. So now go back to the EMFAC model. Now start a new run. Again, select the emission rate run mode. Sub-area. In this case, we assume it's located in Solano County in San Francisco Bay Area air basin. So we have to choose sub-area because Solano County is split into two different air basins. Select the one located in San Francisco and go to next tab. Select analysis year is 2016. Again, we assume this is an annual assessment. Here, in the vehicle category, because the motor coach is a new category introduced in EMFAC 2011, so we should pick this particular vehicle categorization and pick diesel motor coach right here. And we know the fleet by model year. So click the by model year option and pick 2008 model year and control click 2014 model year. Because all motor coaches are diesel, so the fuel option doesn't really matter. And because we are interested in idle emission and the speed doesn't matter, you can pick any speed in order for the model to run. Next, input temperature and humidity. Again, this is a required field, although it probably doesn't matter for idle emission. Next, and we will leave the pollutant and other options as it is. Save the result. Yes, and run. This only takes like 3 seconds on this laptop. Now let's take a look at the output. So again, an easy way to get the emission rate that you need is to filter the result first by the specific process. Here on the parking lot, on the bus terminal project, we are interested in idle. So uncheck the other process that's not relevant and leave only idle emission. You can see that the emission rate are specified by model year, specific model years for each of the pollutants. So that's a relatively straightforward case for the motor coach terminal. Next example is also a bus terminal, but this time it's urban bus. As I mentioned earlier, what makes an urban bus different from the motor coach is that in fact, urban bus is modeled more like a passenger car in that it does not have a separate idle process. This is because the regular idle events at the bus stops during the operation is already accounted for when we develop the running exhaust emission rate. So for urban bus, we suggest to get the idle emission rate, user could use the running exhaust emission rate at the lowest speed, which is 5 mph speed band. Here, as you can see in the partial table here, the EMFAC 2014 specify the speeds by speed bin. The speed bin are defined by 5 mph intervals. For instance, the 5 mph speed bin refers to the speeds that's between 0 mph and 5 mph. And the emission rate at 5 mph speed bin is actually computed at the point of speed of 2.5 mph for light-duty cars and urban buses. So, in this case, we suggest that to estimate the idle emission rate, users should obtain the running exhaust emission rate at 5 mph speed bin and multiply that rate with the 2.5 mph speed, which is the speed that was used to evaluate the specific emission rate. Now let's go back to the model and start to first create the running exhaust emission rate at 5 mph speed bin. Again, choose emission rate in sub-area. Again, we assume this is in Sacramento, so go to next. Analysis year 2016. So all these are same. And here we come to urban bus. You can either choose 2011 or 2007 vehicle classes, which defines the urban bus in the same way, and pick urban bus. Model year, again, like the previous case, we know the population defined by model year. So choose 2008 and 2014 again. In this case, we assume user know the population split by fuel type. So an urban bus could be diesel, gasoline, or natural gas. And speed column, choose 5. Next, temperature and humidity. Save the run specifications and start a run. So this example will take less than half minute. Still, I will queue the run for now and go to the, okay, it's already finished. Now, let's look at output. Here is what the output would look like. The emission rate will be specified by, in addition to other parameters, it will be specified by the fuel type, including diesel, gasoline, and natural gas, as well as model year, 2008 or 2014. And again, like I mentioned earlier, we are using running exhaust emission rate to approximate the idle emissions. So a good practice would be, again, filter the process and pick running exhaust only in this case. So that's a running exhaust emission rate at 5 mph speed bin. To approximate idle emission, you can use the emission rate here multiplied by 2.5 mph, because the running exhaust emission rate is in the unit of gram per mile, and the idle emission rate is in the unit of gram per hour. So to convert the emission rate to gram per hour, you can multiply the emission rate with the speed in the unit of mile per hour. Also, you can observe that in this case, there's no emission rate for the diesel urban buses that with model year 2014. This result is due to our assumption used in estimating the natural gas penetration in future years. So in fact, 2014, we estimate that transit agencies, in order to comply with the public fleet rule, they have to either pick diesel pass or pick alternative fuel pass. Also required by the public transit regulation, the transit agencies are required to report the vehicles, either owned or operated, to the Air Resource Board. So based on the data we collected through the reports, between 2006 and 2012, we observed that more than 85% of the purchases are becoming natural gas buses. So we assume that in the particular case of Sacramento County, Sacramento Air District, that the transit agencies are taking the alternative fuel pass. That will lead to the result that for model year 2014, you will observe 100% of the urban buses are natural gas buses in the Sacramento Air District. So that's the assumption used by the model, and as a result, you will have no emission rate for the diesel natural gas of that particular model year. So now let's close this output and see the next example. The last demo scenario is for a park and ride parking lot located in Sacramento County. The analysis year is 2020. Here, the major vehicles we are interested in are the light-duty vehicles and light-duty trucks, medium-duty vehicles, and motorcycles. On a parking lot, as I mentioned earlier, we are interested in the start emission and evaporative emissions. The start emission are always specified by the soak time interval. Soak time means the duration a vehicle has been parked on a parking lot. So we assume in this case, the modeler collected the soak time distribution, and the main soak time intervals are 5 minutes, 360 minutes, and 720 minutes. We assume that we don't know the model year split or fuel type split. So let's go to the example, go to the EMFAC model. Again, start new case and select the county, Sacramento. The calendar year 2020 and annual analysis. So here for the light duty vehicle category and medium duty vehicle category, the 2011 and 2007 are the same, so you can pick any of the categories and click the specific vehicle classes of interest. Motorcycle. Okay. Since we don't know the model year split and fuel type split, we will keep the result to be aggregated. And pick any speed, putting the temperature and humidity. Leave all the options here on the last tab as it is and click run. Okay, save and run. This run takes about 1 minute on this laptop. So since it covers more vehicle categories, Now let me terminate the run for now and show the result directly. So again, a good practice would be filter the result first, as it might contain information that is not relevant. So to have a better view of the output structure, I'll select one pollutant. Let me pick rock as most of the emission process, evaporative emission process. So now you can see that emission rate are outputted for all different processes. Let's take a look at the specific process on this parking lot, one at a time. So first, let's look at the start exhaust. Start exhaust is always specified by the time interval. So this column is called speed and underscore time. Depending on the process, this column contains different values. If this is a running exhaust, here that will be the speed bin. But for start exhaust, this number here refers to the soak time interval. In this particular case, user collected information, observation that vehicle mostly park 5 minutes or 360 minutes or 720 minutes. You can filter out the result, and this will give you a much clear view of the emission rates that's going to be useful for this particular project assessment. So this is the start exhaust by soak time, and for the specific temperature for each of the vehicle classes. Okay, and clear the filter, and let's do the filter again for rock, and take a look at the rest of the process, evaporative process that we are interested in, including hot soak, multi-day diurnal, multi-day resting loss, partial day diurnal, partial day resting loss, and check these two running process, and also uncheck start, since we already checked it out. Now these emission rates, clearly they are only vary by temperature. The evaporative emission rates vary by temperature and vehicle classes. So those will be useful for this particular project assessment. Okay, let me close this file. Save. And go back to the presentation. So for more information, you can find in the EMFAC2014 user guide, technical documentation. Also, we specially published a handbook for project level assessment with 5 different cases at the end of the handbook. If you have more questions, you're welcome to contact us at EMFAC2014 at arb.ca.gov. That will conclude my demonstration, and we will accept some questions. And after that, we will have Hong Liu talking about the web database tool.
Thanks, Jen. We have one question related to the project level assessment tool, and we'll utilize this 5-minute time frame maybe for some other technical questions. So there is a question from Sam Wang. There are more and more buses using CNG compressed natural gas in California, but it seems there's no CNG emission factor from buses or any other type of vehicles provided in EMFAC 2014. Can you suggest a reference that we can obtain from those CNG emission factors?
Yeah, I think this is important news. At this point, yeah, we're not prepared to give a specific reference.
But in terms of the emissions, yeah, so emissions from the natural gas vehicles are combined with the diesels. However, in our project level assessment tool, we're providing the emission rate for the project level assessment. We're providing the emission rates of the CNG or natural gas urban transit buses and natural gas refuse trucks separate than diesel. So that's one of the sources you can use. But in terms of the emission or for conformity assessment or for the default emission inventory purposes, still EMFAC 2014 is combining diesel and natural gas together. No, I guess that was a confusion. So there is another question from Jinghua Xu regarding how to install EMFAC on the MySQL server and basically having a MySQL cluster. So the question is, since there are multiple users of EMFAC 2014 in different locations within our company, is it possible to install MySQL cluster on a server so that user can access and run EMFAC 2014 on a server without installing MySQL on every individual computer?
Yeah, I think that's doable. As Andy showed you earlier, there is a place you input the server information to specify the user information. You actually can just install the MySQL server on one machine on server, and install your EMFAC model on different computers. And when you refer to your database, in the setup, you refer to the server. In the example, I believe Andy used the local host where you input 127.0.1, and in that address, you can actually put in the server's address.
Well, just a modification to that, EMFAC 2014 was not designed as a multi-user software. It uses some common schema such as EMFAC 2013_run for all runs and output. So if you have two people running on the same server at the same time, you can't predict the results. We had that problem when we were developing it. Just keep that as a caveat.
Yeah, thank you, Andy. Yes, that's true. So it will be a better practice if you set up server with multiple users, only one user execute the program at a time.
Yes.
Thank you. So Andrea and some other folks have some question regarding how to install MySQL either on Mac or on a 32-bit Windows 7, or how to troubleshoot the MySQL to import a database. We'll get back to you at the end of this. At the end of this webinar or after this webinar, we'll get back to you guys regarding this troubleshooter. You can contact us at the EMFAC 2014 at arb.ca.gov for more information. So with that, maybe we